Shane. Hello, Shane. Can you hear me? Can you hear me?
Yes, I can. No problem at all.
Okay, we can hear you good. Yeah, sorry, we got a little technical difficulties just now with a video. So when you're ready, we can start to your session, and sorry for the interruptions.
No problem. So hello, everyone. Thank you very much. Hello, everyone. It's very good to be here today. I'm going to share my slides, which you should now be seeing. I'm the general manager of the OpenChain project, so I help manage the ISO standard for open source license compliance. I'm going to explain a little bit about our standard and about how open source intellectual property approaches can help with open hardware. Let's jump right in. OpenChain is a project. It's basically like an open source project supported by many companies. On this slide, you can see our platinum members. These are the companies on our governing board. You will notice some Chinese companies here. So Honor, Huawei, and Oppo are all part of the OpenChain governing board. The companies are very different, from silicon to cloud technology to automotive, but they have a shared interest in great intellectual property management around open source. Now, the way we approach intellectual property in open source is through an ISO standard, ISO IEC 5230. This is the international standard for open source license compliance. It is designed to work for companies of all sizes in all markets. Let me explain how it works. The short version is that our international standard identifies the inbound, internal, and outbound process requirements for a company using open source. Our standard is not designed to be super complex. It's not designed to be super detailed, and it's not designed to be tied to one license or another. Instead, it helps you get the processes required to manage all open source licenses. Now, our goal is to make a trusted supply chain. So our basic concept is that company by company, the supply chain starts using this ISO standard, and this makes compliance and collaboration much easier. Here are some of the companies using our standard. This list of companies is just the companies that decided to announce via our website. Of course, there are hundreds more. You will see some Chinese companies on this conformance slide and companies from all over the world. One of our most recent conformance was ZTE, and they were third-party certified by the Chinese organization CAICT. Now, we have an ISO standard for license compliance, but if it was just an ISO standard on its own, that wouldn't be so helpful. We have to give people some ideas, some suggestions of how they can fill the process points, how they can implement the standard. We don't tell people what to do in their processes, but we give them lots of examples. For example, we have policy templates, slides to educate people around open source, slides to explain automation. We also have lots of case studies from companies using our ISO standard, companies certifying others with our ISO standard, and supplier material for example, to help companies with no knowledge of open source get ready for addressing open source intellectual property. Now, open source is all about collaboration, and so is our ISO standard. We have work groups in China, Japan, Korea, Taiwan, India, UK, and Germany, as well as North America. This focus on community captures the spirit of the reason we are here. We want to collaborate on good technology. The community is mostly user companies, people using open source to make great solutions. This gives a very strong, clear mission for everyone. Of course, there are plenty of vendor companies and service providers in our ecosystem too. On this slide, you can see some of our official partners. On the next slide, you can see some of our official third-party certifiers. You'll notice the organizations, CAICT, and also the China Academy of Sciences are both certifiers in mainland China. Now, people don't need to be third-party certified. They have freedom of choice. They can self-certify, they can have independent assessment, or they can have third-party certification. The idea here is to use the ISO standard to address open source intellectual property. There are plenty of options. Now let's jump into what that means and how it can help open hardware. So our approach allows for collaborative, effective license management. There are many open source software licenses, and we do not address them one by one. Instead, we have a process framework to manage all of the licenses. The reason we are doing this is very clear. We want to reduce errors, we want to reduce remediation time, and we want to reduce resource costs. Now, the question is, does this solve for all intellectual property concerns around open source? Open source software licenses generally focus on copyright. These are copyright licenses, mostly talking about copyright. But the majority of popular open source licenses also contain patent clauses, licenses like Apache, licenses like GPL. This means that in practice, most open source licenses have coverage across the two major areas of intellectual property concern. Now, I want to give you some context. Open source provides value because we pool our resources and we apply those resources to shared innovation. To make open source work, we need to have an equal playing field. The companies need to all feel they have equal and fair access. Otherwise, they will not participate. The basic terms for open source are that everyone involved can use, share, study, and improve the software. By covering copyright and also having patent clauses, we provide an environment that makes it easier and safer for companies to use, share, study, and improve software. So the basic concept is we need collaboration, we need it to be fair, and everyone needs some basic rights. That is the context for our intellectual property choices. Now, one of the most important points here, and this is very relevant for open hardware, is that the stakeholders in open source have a strong incentive to support rather than prevent sharing The basic motivation here is that more sharing is good. Now, this means that the basic motivation for companies in open source is to fix or avoid IPR concerns. Companies do not seek a confrontational stance. It is not of benefit in open source to have conflict. This means the basic motivation in our ecosystem is to fix problems, not to fight about them. Okay, so that's very important to remember. Open source software requires collaboration to provide value. So everything we do around intellectual property is biased towards collaboration. Now, how does this map to open hardware? Does it map perfectly? Open hardware is about designs that then can provide value in products. This is a little different from the general approach of open source software. In open source, we're focused on platform technologies, stuff like operating systems, cloud infrastructure, but we don't really make product level code. So the basic model of open source is to work together well on platform technology, but to have very strong competition around products. This is why the same software is in a Fujitsu air conditioner, an LG TV, or the new BMW iX. The same basic open source code is in all of this, and all of the companies can collaborate. But the products are different, and each of those companies is very strong in promoting their products. By the same measure, a Samsung television and an LG television has a lot of the same platform code, but these are two very aggressive rivals in that market. So once again, in open source, we collaborate on platforms and compete on products. The challenge for open hardware will probably be finding the line between the shared space, the platform, such as CPU cores, and then the moment when you have a product, such as a full system on a chip, SoC. In open hardware, these lines are not quite drawn, and that's probably going to lead some market tensions until those lines are drawn. Maybe open source software has an advantage. We know that open source software isn't that effective on product, but it's great on platform. In open hardware, it's still more experimental. And while things like RISC-V are focused on stuff like CPU cores, there are also discussions about full system on a chip and so on. The line between platform and product is not clearly drawn yet for the market. And for that reason, the experience of open source software does not perfectly map to open hardware. But of course, open hardware can learn a lot from open source software. Here's what you can learn. The first is to have the IPR boundaries between the shared platform and the product level. So for open source, we have very clear boundaries between shared platforms and product level code. In open hardware, perhaps there's a need to have clear boundaries between shared platform technology and product level designs. The licenses used need to provide extensive protection on the platform level. And that's a very important point. Open source faced challenges in the early days as people tried to have licenses that didn't provide extensive protection for platforms. And that made it hard for people to work together. It made it hard to have momentum. So it's important to avoid gotcha issues, surprise problems, such as patent exposure on platform level technology. It's fine to have strong patents on products, but if you're looking at open hardware platforms, if you're looking to have an active collaborative ecosystem, you need to make sure that patent exposure is addressed and minimized. And the final point is to avoid fragmentation of platform development. There is no point in trying to make 100 different types of CPU cores. A CPU core is ultimately just a commodity. And a lesson learned from open source is that it pays to have some excellent platforms like the Linux kernel. It doesn't pay to have dozens of different types of the same platform. We don't have hundreds of open source kernels that are successful because it's more effective to collaborate on the Linux kernel than to split our attention. The same is probably good for open hardware. So to review that, it's important to have clear boundaries between platforms and products. It's important to have strong protection around things like patents so that the companies involved all feel equal to collaborate on the platform. Compete on the product, but collaborate on the platform. And don't have too many platforms. If you fragment your research and development, you're not getting the same value as if you pool it. Open source basically is a way to pool research and development. Open hardware should probably be the same. And finally, one of the most important points is to always put the community first. The stakeholders, the companies making hardware, are going to be the most important part of your success. So the environment needs to be welcoming and supportive to bring more and more companies inside. And there, I end my presentation. And of course, I'm happy to take any questions if you have them. Okay, if there are no questions, I will hand over to the next speaker. Thank you very much for having me here today. I will be on a panel. Yes, of course.
Okay, I have a question for you. How to prevent export control risks in open source software, especially to prevent those provisions in the US export administration regulations that target open source software?
It's a very good question. So mostly open source software is exempt from export control concerns. The issue of export control is usually tied to cryptography. And generally, it's very clear in open source what part of the code is cryptography and what is not. This means it's very easy to replace something limited by export control with another option. So basically for open source, export control is usually a very small challenge, usually tied to cryptography. And because of the design of software, if some kind of algorithm approach is limited, we can swap in another one. This was a bigger challenge probably 30 years ago when we had relatively few options on things like public key cryptography. And in the early days, in the 1990s with open source, we had some real challenges with US export control and open source cryptography. But the situation has changed a lot. Some very important and very good cryptography is now not under export control in, as far as I know, virtually all jurisdictions, except those which may be under United Nations sanctions. And as far as I know, countries around the world innovating around areas like cryptography are nowadays generally sharing pretty openly what they do. Perhaps this is because we've become so good at things like cryptography, all of it is excellent and it's not really a secret. So I've noticed that even as we get ready for quantum cryptography, teams in China, teams in Europe, teams in the United States are very openly publishing their findings. So we can move from things like public key cryptography into lattice-based cryptography. Yep, so in summary, at the moment, export control has very small impact on open source. There are some impacts, but we can usually swap the code super easily. I'm not aware of any major open source platform that has had any issue with international code distribution. Arguably, the United States is currently the most aggressive country trying to limit certain technologies, but they have basically excluded open source from those limitations. And that's why in places like the Linux Foundation, we have a totally international community. As you could see in the OpenChain project, we have pretty equal balance between United States, Europe, China, Japan, and so on in participation. That's also reflected across other projects in Linux Foundation that make code. The other topic would be, what about export control with United Nations sanctions? Now we have not just sanctions against, let's say, North Korea, Iran, we have sanctions against Russia. Yeah, that's more difficult. And it'll probably get worse, not better. We're going to probably face interesting challenges. Individual countries have sanctions against Russia right now. United Nations sanctions are probably likely to escalate. We may have a situation where our partners in Russia become hard to work with because of the situation. When it comes to United Nations sanctions, I think basically it's unavoidable, and we just have to wait until the situation improves. That was a great question, by the way. Thank you.
Thank you. Thank you, Sean. Thanks for your time and thanks for sharing the excellent topics. Thank you.
My pleasure.